Specialized protective clothing has been around for thousands of years. From ancient warriors to medieval knights, protective garments were worn to help prevent injuries and save lives. The materials that were used to make these types of clothing, like metal and leather, worked well in those early days. But as weapons became more sophisticated, the usual materials began offering less protection. The types of materials that were used to make protective clothing remained relatively unchanged until about the mid-1960s, when a research scientist named Stephanie Kwolek introduced a revolutionary new material called Kevlar. This material was not only lightweight and durable, but was about 5 times stronger ounce for ounce than steel. With this development, the world of protective materials changed forever. Today, stronger, lighter synthetic structures have opened up new and exciting avenues in the development of protective materials. These materials are being used in everything from sporting goods to space applications. To help shed some light on how these materials have changed our lives, I spoke with Dr. Jeffrey Hinckley at NASA Langley Research Center to find out how it works.
If you look at the history of materials in humankind, you see the Stone Age, the Bronze Age, and then the age of steel, which is sort of the Industrial Revolution. We're in the course of another revolution now, high-performance materials that can combine the strength, the stiffness of steel with other properties, electrical conductivity, the ability to be formed plastically, and to even stop bullets. Another example is Kevlar, which is used in armor protection for our troops. And of course, glass fiber is familiar to some people, and glass fiber boats, and so on.
So we've talked about Kevlar. How does a thin material like that stop bullets?
You have here the flexibility of a fine fiber, very tough, resilient material, and twice as strong as steel at 1/5 the weight. And Kevlar is also a good material for penetration resistance, cut resistance, because of the way it's fabricated. Actually, the molecules that make up the polymer are stretched and aligned such that in order to break this material, you actually have to break the molecules.
To understand how a flexible material like Kevlar can stop bullets, just think of a net on a soccer goal. The net strands are interlaced together, which are in turn attached to the frame of the goal. When the ball is kicked into the goal, each tether extends from one side of the frame to the other, dispersing the energy from the point of impact over a wide area. This forces the ball to stop. The same basic principle applies to bulletproof vests. The vest is made up of layers of fabric containing incredibly strong fibers. When a bullet hits this material, the energy is dissipated, forcing it to stop before it can penetrate the vest. Why is NASA interested in using these materials?
Kevlar, as a bulletproof vest material, is essential to protecting the astronauts and the equipment, for example, on the space station.
Space is a very hostile environment. Extreme temperatures, radiation, and small meteorites can make working there very dangerous. For example, the International Space Station is orbiting the Earth at close to 18,000 miles per hour. At these speeds, even a piece of debris the size of a grain of sand can damage the station. To help decrease the chance of an object penetrating the outer skin, the space station wears a type of bulletproof vest. Layers of aluminum, ceramic fabrics, and Kevlar form a blanket around each module's aluminum shell. If an object strikes the station, this blanket of protective materials helps to dissipate the energy of the object, helping to keep the crew safe inside. I know that composite materials are still relatively new. How do you think they will change in the future?
Maybe one of the most exciting examples is carbon nanotubes. These are pure carbon and unbelievably small, but they're in the form of a fiber. This is a material that was discovered in the 1990s and is probably stronger than anything we've known up till now. It's perhaps stronger than diamond.
Wow.
The trick is to figure out how to make something useful out of these tiny, tiny tubes. This is 10,000 times smaller than a human hair. And so the trick is to use this material, which even under a microscope just looks like soot, into a strong, lightweight composite material. And so our chemists are working on that. An idea that's really on the drawing boards is the idea of a self-healing material. You can imagine a spacecraft that's going to be in orbit for 20 years. It would be nice not to have to service it. So we conceived the idea of a material that would heal itself after it was damaged. And I have an example here. This is a sort of a conventional plastic material that was struck by a 9mm bullet. And as you can see, it shattered and left a hole that's just a little over 9mm in diameter. Here's a new material that was invented here at NASA, and this also was struck by a 9mm bullet. The bullet went right through, the bullet was not stopped, but there's no hole. We can imagine that self-healing materials would be useful on aircraft too. Right now, when an aircraft is brought in for service, they look all around it for cracks. And they're looking for a critical crack, which on some commercial jets might be as much as 4 inches long. When they get to the critical crack size, they repair it. Well, we can imagine a composite material made with self-healing matrix, self-healing plastic, that could heal itself and the cracks would never grow. The exciting thing about working for NASA is that it is always something new. And we get to sometimes see the results of our work coming into commercial use.
So the next time you hear about somebody getting their life saved by a bulletproof vest, you know how it works. I wonder if these things work well with paintballs.